With so many different types of SAT math problems, it can be difficult to decide where you want to put your attention and your time. To get the most bang for your buck, here are some question types that have been showing up on every single test. First up, we've got questions that look like they're going to require the quadratic formula. So if we take a look at the quadratic formula, we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. Because of this square root, a lot of the time you end up with square roots in your answer choices. So when we look at this, it seems like we might have to use the quadratic formula, which is a little bit annoying. And in truth, we could use the quadratic formula for this one. We could also use substitution, which is again going to be annoying, but there is a way that looks like it's going to be faster, and in this case it would be, and then there's a safer, fast way. Let me show you. So the way that looks really fast to me is testing out the answer choices. This strategy is also known as back solving. And the reason this looks very tempting is if we take the first answer and we plug it into the top equation, we get 1 plus the square root of 3 minus the square root of 3 equals 1. And that's definitely true, right? Because we're getting rid of the square root of 3, 1 equals 1. And if you were just testing the top equation, you would get lucky and you would answer A, because that does happen to be the answer. But the problem is, if you're being careful, which you should be, you get down to C and the same thing happens, right? You have 1 plus the square root of 5 minus the square root of 5. And yeah, that equals 1 too. So now at this point, we're going to have to plug them into the bottom equation, which, as you can see, is not going to be nearly as fun. So what would I recommend? Believe it or not, we can use Desmos on this. I know it doesn't look like it because of the radicals, but bear with me. If I pull it up and we go ahead and put in our system of equations, it is asking us which ordered pair is a solution. So if we can match one of the answers to one of our solutions, we should be good. So if we look at this one, we've got 2.732, 1.732. And from here, it's as simple as plugging in our answers to see what they look like in decimal form. So A, we've got 1 plus square root of 3. And by the way, I typed in SQRT, a little shortcut for you. And by golly, that's 2.732. Okay, well, what about the square root of 3 by itself? SQRT. 1.732. So, luckily it was A, so we got our answer. And this time we know for sure it is a solution. But if it didn't work, we'd go through and then we would end up getting our answer that way. So a little extra step, but I think a lot faster than some of the other methods available for this one. Next up, I've got the rule of 180. And the rule of 180 is more than just one rule in a way, because we can think of the rule of 180 as 180 degrees in a triangle, which is what it is in this case, but also 180 degrees in a straight line, which it also ends up being. Along with that, we've got a little bonus, which is isosceles triangles that will come into play for this one. So let's take a look here. We know that our goal is just to find out what x is, right? What is the value of x? And with geometry, I highly recommend labeling everything first. So let's do that. We know that ABC is 45. So I'm going to stick a little 45 up here. And in case you're not sure how to read these, basically the letter in the middle is the angle that we're looking for. And then ACD is 104. So ACD, this is 104. And then importantly, I almost skipped this. The very first thing it says is AC equals CD. So we can mark that AC equals CD. And this is super important because this goes to the whole isosceles triangle thing that I was talking about. If you have two equal sides, it means the corresponding angles are also equal, and you have an isosceles triangle. So basically D and A, these two angles are also going to be congruent. And now we can pull in the rule of 180, right? Because we know that the top of this big triangle is 104 degrees, and we know that there's only 180 degrees in a triangle. So if we take 180 and we subtract 104, we get 76. And we know that that has to be split up between these two angles, right? So we can label a little bit more. Split up that 76, that is to say divide it by 2, and we get 38. So now we also know that both of these angles down here are 38. And now we've already begun to engage in what I like to call ring around the rosy. We're going around, we're seeing what can we figure out? What can we figure out that's going to get us closer to that x? And we are actually really close to solving this now. Just a couple more things. We're going to use the rule of 180 again. This time it's going to be the straight line rule. We know that this is a straight line, so it's 180 degrees. We know that this side of the straight line is 104 degrees. So again, we're going to do 180 minus 104, but we already did that. We know it's 76. So we can label this angle 76. And now we can use the triangle rule of 180 to get the last angle in this triangle. Let me switch colors here. So we got 180, and this time we're going to subtract 45, and we're going to subtract 76. And I'm just writing this out so you can see what I'm doing, but just use your calculator. That's 59. And then there's another rule here, which is the vertical angles rule. Basically, whenever you have two tips touching like this, those angles are congruent. So if that's 59, we know that this is also 59. And then, as you can see, we just have to do that rule of 180 one more time. Now we're subtracting the 59 and the 38. And we get 83, which is x. And that's our answer. So I said the rule of 180, the little bonus rule of isosceles triangles. We should probably add another bonus rule in there, which is vertical angles. So really, it's just common geometry rules that you ought to know. And these are rules that are not on the reference sheet. So you really do need to have these memorized, but I think they're pretty easy. By the way, at the time that I'm recording this, I am accepting new students. So if you want to work one-on-one with me, go ahead and use the link in the description to sign up for private tutoring. Next up, we have
so many linear equations.
There are going to be so many linear equations on your exam. How do I know this? Because 32% of the questions in College Board's question bank are linear equations, so they're inevitable. And something that is really helpful to remember with linear equations when they are word problems is what each component of slope-intercept form represents. So just a quick refresher for you, we've got y equals mx plus b. And you should know that y is y, x is x, m is the slope, and b is the y-intercept, right? But in the context of a word problem, what do these things represent? Well, y is going to be your total. X is going to be the thing that affects your total. This is often time or a number of items being purchased. M is your constant rate of change. So if X were time, then M would be like, miles per hour. If X were an item that you were purchasing, M would be the cost of that item, right? So it's the rate of change in relation to X. And then B, your y-intercept, is your starting point. All right, with all that in mind, let's actually take a look at this problem here. And I do like to go to the main question first and decide how much of the rest of the question I want to read based on that. And the main question says, what is the best interpretation of the slope? So this is perfect. We can look at our little cheat sheet here because it's all about representation, interpretation, right? So the slope, according to what we just talked about, is a constant rate of change. So I'm going to eliminate any answer that is not a constant rate of change. Each game costs 25. That would be a constant rate of change, right? We talked about it being, the cost of things that are being purchased. The video game system costs 100. And I can already tell what's going on here because we know we're going to have multiple games for one system. So the system would be kind of like the starting point, the y-intercept, because you need to buy the system before you can start playing games. But we could also look at the other sentence here, and it tells us that more or less. But either way, B is not a constant rate of change because we're only going to buy one video game system. Again, C, only one video game system. And then D is also a constant rate of change. Each game costs 100. So now I just need to figure out, is the slope actually 25 or is it 100? We could grab a couple points and use the slope formula, but I'd rather just eyeball it because there are some pretty clear points here, right? We just need to do rise over run. So here we have 100, and then we want to draw a little staircase. So rise over run. We go up 25 because once we get here to 1, it's 125. Same thing here, rise over run. We can see that we're going up by another 25. So my answer is A. Next, we've got margin of error questions. I feel like these are sort of a sleeper that not a lot of people talk about, and they're not super common. If you're going to run into one, you're probably just going to run into one on the exam. But if you know how to handle them quickly, those are extra points that are very easy to attain. Basically, with margin of error, we need to remember that a margin of error says it is likely that the real percentage is either, this amount higher or this amount lower within that range. So for example, if I said, I did a study and according to my study, 64% of cats are evil, but there's a margin of error of 4%. That would mean it is likely, and it's important that we remember likely here because we don't know, but we can say with confidence that it's likely between 60%, so that's 64 minus the 4%, and 68%, so adding that percentage to the 64% of cats are evil. So that's all we need to remember for margin of error. The word likely, and we're going between a range of subtracting and adding the margin of error. And like I said, I do like to start with the main question, which is why I immediately saw that this was a margin of error question. It says, which is the correct statement on the given margin of error? And the reason that this is so fantastic is we don't have to look at this chart. We don't have to look at the whole question. We just have to figure out what the margin of error is and then sort of cherry pick from there. So here it says the estimate of heavy texters is 30%. So that's like my 64% of evil cats. And then the margin of error is 3. So in my head, I'm thinking it's likely that 27 to 33% of teens are heavy texters. And notice I'm not even looking at this chart because of this. So hopefully I don't have to. All right, and I'll write that down so we don't forget. Get rid of the cats. Cool. All right, now we eliminate answers that will not match that, basically. Approximately 3% of teens who are classified as heavy texters are not really heavy texters. No, it is not possible. Immediately, I'm seeing not possible. That's an extreme absolute statement, so B is probably not going to work. That sort of language is something you definitely want to look out for. Not possible that the percent of teens who are heavy texters is less than 27. So it's not likely, but it is possible. So that's why we get rid of B, and that's why I emphasized the likely. It's really important there. C, the percent of all U.S. teens who are heavy texters is 33. That's another extreme absolute statement. It's saying it is. It's not using likely. So C is out. It's possible, but it's not just the truth. And then D, it is doubtful. So doubtful is sort of the opposite of likely. It is doubtful that the percent of teens who are heavy texters is 35. Yeah, because it's likely it's 33 at the highest. So it would be doubtful that it's 35. So D is our answer. Next up here, we have what I like to call scary constants. And they are scary, but we shouldn't be that scared of them. This problem in particular is rated at a difficulty level of 3. So basically, the highest difficulty level according to College Board. But there are 2 easy ways that we can solve this. For sure, we could do a whole lot of substitution and solve it on paper, but for systems of equations, your first instinct should be to try out Desmos if you don't see another quick solution. Now, I don't think Desmos is the fastest way to solve this one, but let me show you how that would work real quick. Basically, we put both equations into Desmos, which I've done here, and because there's a constant involved, we're going to have to add a slider. So you click this little button that says Add Slider. And then what the slider is going to do is allow us to change the value of t. And the question is asking, what is the value of t? So The only hint we're given is that the system has no solution. No solution means the lines never touch. So I would need to move this slider around so that the lines are not touching and that they will never touch. Basically, they need to be parallel. And you can see when I get to 8, they are indeed parallel. Visually, it's kind of hard, but if you zoom in, you can tell. And if you wanted to double check, you could plug 8 back into the equations to make sure it works. So Desmos would work like that. However, I think there's actually a really fast way of solving this. So like I said, a system of equations with no solution means they never touch. As I just showed you visually, it means they are parallel. And if they're parallel, it means they have the same slope, which means they should have the same coefficients in front of x and y. Another cool thing is, regardless of if it has no solution or infinite solutions, we can focus on those coefficients in front of x and y, because no solution means that the constants, that is to say the leftover numbers that are not attached to x and y, they're never going to equal each other. With infinite solutions, they will equal each other, but we could still just focus on the coefficients because they're also going to equal each other. Anyway, let me stop saying equal each other and actually show you what this looks like. So I am just going to worry about getting the number in front of x to be the same because I know they have the same slope. So that's literally all I'm going to do. So the first thing I want to do is get these looking more like each other. The bottom equation, we have y on the left side, but then x is on the right side. So I'm going to just do a little flippity-doo-dah-day here and make that the case for the top equation as well. I'll start by moving the 10y over to the left. So we get negative 16y because I subtract 10 from both sides. And then I want my x to go over here. So I'm going to subtract 4x, which means that would equal negative 4x. And remember, I don't care about the constant, so I'm not going to even worry about it. I'm just going to leave it out of the equation. And I'm not particularly fond of negative numbers, so I'm just going to multiply this whole equation by -1 to turn these positive. Now, let's write the bottom equation, again, omitting the constant, because we don't care about the constant. Doesn't matter. Ty equals 2x. All right. Now, remember what I said. They have to have the same coefficients. So right now, if we have 4x up here and 2x down here, how do we get the bottom to be 4x? We just multiply the whole equation by 2. So then we get 2ty equals 4x. All right. And remember what I said, they have to be the same coefficients. So the 4s are matched up. That means that the y coefficient should also be matched up. So if we get rid of that y now, basically these should equal each other. Moving over here real quick, 16 equals 2t, which means t equals 8, right? We divide by 2. So our answer is 8. And I was writing all that out for you, but honestly, most of that, if not all that, should be able to take place in your head once you get used to it. For me, as soon as I wrote down these guys here, I'm immediately saying that we multiply 2 by 2 to get to 4x. So then what do we multiply by 2 to get to 16? 8. And at that point, I already know the answer is 8. So that's why it would go really quickly for me if I use this method instead. Definitely look for shortcuts when you come across these scary looking constants. For sure you can use Desmos, but as you can see, a lot of the time there's even better shortcuts. All right, and here we have percentages, and you are certainly going to be encountering percentages on the SAT. If you want me to make a more detailed video on the different types of percentage questions, let me know in the comments, but for now, let's just address this. We know from the main question that we are looking for the discount. And I like to start with the main question so I don't get distracted and lose sight of my goal. It says the total cost of this purchase was $75. That was the total cost. Emma's going to get a discount code to save 15%. That's subtract 15 off the total cost. So basically, we're taking that 75, we're subtracting 15%. And some of you smarty pantses out there might be like, ooh, I know. If we multiply 75 by 0.85, we're going to get the amount that Emma paid. And you're right, that's totally going to work. But remember, we're not looking for what she paid. We're looking for the discount. So we actually just want to multiply by that 15%, which is, 0.15. Throw that into Desmos if you want, and we get 11.25 as our answer, which is B. And if that last question looked a little bit different, that's because it's not from the College Board question bank. It was actually designed by Test Prep Posse, which is a really cool group of tutors with over 100 years of experience combined. That was just one question out of 50, but you can download the entire activity pack of 50 extra math questions using the link in the description. It's completely free, and every question in there was designed to replicate the types of questions you're actually going to encounter on test day. So I would highly recommend that you click that link and get those free questions. You're not going to find them anywhere else.